We have discussed unit tangent vector, and we're going to discuss principal normal vector. Principal normal vector is a vector which is orthogonal to the unit tangent vector. This vector, and as I have shown you in this diagram, this is our unit tangent vector, and then this is our principal normal vector. The angle between them is 90 degree. If I am having this curve, and this is my unit tangent vector, then this is principal normal vector. This is my unit tangent vector, and this is my principal normal vector. So the angle, we can say here we have the tangent vector dot the normal vector as they are orthogonal to each other. Then the dot product of these two must be equal to 0. That is a proof that they are orthogonal to each other. So definition of this one, when we are having this R of t is a smooth curve, then R dash of t is also smooth, and we having t of t is also smooth. So we can define here the derivative of this one, and we say my n of t, then the unit principal normal vector is equal to t dash of t over magnitude of t dash of t. This is my mathematical definition of my principal normal vector. That's we find we having r dash, we can find t dash, tt, unit tangent vector. Then we take derivative of unit tangent vector. Magnitude divided by the magnitude of unit tangent vector, we get principal normal vector. So I give you some examples where we are going to find the, obviously because to find the principal normal vector, we need unit tangent vectors. We say we have the problems like this one. We want to find the unit tangent vector, also principal normal vector. So I give you the examples for that. So we have this example, and we want to find the unit tangent vector and principal normal vector in this one. Again, the vectorial function r of t, there is cosine ti plus sine tj and tk. So we know that first we want to find the unit tangent vector. We need r dash of t and then magnitude of r dash of t. We say here, first number one, we find unit tangent vector. Unit tangent vector. For this finding unit tangent vector, we need here r of t is given to us, that is equal to cosine ti plus sine tj plus tk. I take the derivative of this one and write r dash of t. So my r dash of t is equal to minus sine ti plus cosine tj plus k. Now I need r dash of t magnitude to find my unit tangent vector, and we just take the magnitude of r dash of t is equal to square and add it, sine square t plus cosine square t plus square of 1 is 1. So we having here sine square t, cosine square t is equal to 1. So we get here 1 plus 1 under the root. We get here 2 under the root. Very easy. Now we can write our unit tangent vector over t of t is equal to 1 upon root of 2. This is my r dash. I will just write the formula for the reason that is to make for completion, that we having r dash of t divided by r dash of t magnitude of this one. Magnitude of r dash of t, that is equal to 1 upon root of 2, and over r of t is, r dash of t is minus sine ti plus cosine tj and plus k. So I can divide by root of 2 if I like, or we just keep it like this one. So this is my t of t. Now, and the second I'm going to find is my second is principal normal vector. This is my n of t, and as I mentioned it, what's my n of t? My n of t is equal to t dash of t over t dash of t magnitude of this one. So I have here t of t, and now I just proceed and further and find here t dash of t. So my t dash of t, 1 upon root 2 is a constant. We keep it like this. Then derivative of sine t is minus cosine ti. Then derivative of cosine is minus sine tj. And derivative of this is 1 is 0, 0k. Now I want to find the magnitude of t dash of t. So just we take the square of each of them. We take root of 2 below this one and get here cosine square t over 2, and take here under the root plus sine square t over 2, because we are taking square of this one and taking inside, and plus 0. So this is sine square t, cosine square t is equal to 1, and we get here again 1 upon root of 2. We can write here 1 over root of 2, that's my t dash of t. Now my n of t is that we're going to divide t dash of t with this one. So my n of t is equal to t dash of t over t dash of t magnitude of this. So here is I am having here t of t. T of t is 1 upon root 2 minus cosine ti minus sine tj plus 0 times k. You can write 0 times k or you can leave it. 1 upon root of 2 divided by this one, this is cancelled, and we can simply get here minus cosine ti, and we are having here again, we are having here minus sine tj, and that's my n of t. I write it again here, my unit tangent vector n of t. As we calculated, that's equal to principal normal vector is minus cosine ti minus sine tj, and that's my solution. So we define now the curvature of the curve, any space curve given by r of t, f of ti plus g of tj plus h of tk. So we already discussed the unit tangent vector. So we use that one to find the curvature. So the formula for curvature is the t dash of t divided by r dash of t. So we discuss r dash of t we have already found, and from r dash of t we found t of t, and then for unit tangent principal normal vector we find t dash of t also. So we use that formula, the t dash of t and also r dash of t, to find the curvature. I'm going to take this example, find the curvature of the curve C given by the vectorial function r of t is equal to 2ti plus t square j plus 1 by 3 t cube k. I find r dash of t. To find it, r dash of t is equal to 2i plus 2tj plus t square minus t square. We are having here minus sign, and 3 we just take the derivative. This 3t square, 3 is cancelled, and we get here minus t square k. So here to find t of t, we need the magnitude of the vector r dash of t. We find this one, we are having here the root sign, and we get here 4 plus 4t square plus t to power 4. So this is my magnitude of the vector. I can find my t of t. My t of t is r dash of t divided by r dash of t, magnitude of this one. So I can write this equal to 1 over root of this my r dash of t, 4 plus 4t square plus t to power 4, and then we are having here 2i plus 2tj minus t square k. So we are having here this result for that one. So you can see here the denominator of this one is very simple. We are having 2 plus t whole square. That if we open it, we get here 4 plus 4t square plus t to power 4. So if I take here root of this one, 4 plus 4t square plus t to power 4 under the root, that's mean I'm taking root of 2 plus t square whole square under the root. Square root is cancelled, and I get here 2 plus t square. So I simplify this one and can write my t of t, the unit tangent vector, is equal to 2i plus 2tj minus t to power 2k over 2 plus t square. Now I find here r dash of t, and we take the quotient rule for that one. This is equal to root of 2 plus t square whole square, and I am having here 2 plus t square, and take the derivative of this one. Derivative of 2 is 0. We get here 2j minus 2tk, 2tk. We have minus sign. Then we are having here 2i plus 2tj minus here we are having t square k minus t square k, and we multiply this one by derivative of this denominator. This become 2t. I simplify this one, and simplification that give me here the t dash of t is equal to, my simplified form is, you can just go ahead and simplify this one, 0 minus 4 ti, and then I have here plus 4 minus 2 t square j, and then I am having a minus 4t minus 4 t k, and we are having here this we just divide by 4t k, and we divide this one by our t 2 plus t square whole square. So this is my t dash of t. Now I have the formula when I want to find the curvature. So in curvature we have seen the formula is t dash of t magnitude of this one over r dash of t, magnitude of this one. We're having the magnitude of r dash of t, we want to find the magnitude of t dash of t, and here we square each of the component and divide by this one, and when we make this one, this is equal to another root sign 16t squared, then here 4 minus 2t squared whole square plus 16 t squared, then we just having here 16t whole square, and similarly we divide here the denominator also, we take the square and root of this one and take it, so we get here 2 plus t square. We simplify this one and we simplify this one, we get here this equal to 2 into 2 plus t square, and over this one is equal to 2 plus t square whole square, here whole square, and simplify this one, get here 2 over 2 plus t square. So this is my t dash of t. Now I can write here this t dash of t over r dash of t. We have calculated here r dash of t before. This is my r dash of t. We calculate this my as I mentioned, this was my 2 plus t square. I have just given the details here below. That's how we get this one, and this was our formula. And similarly, we get here this. We divide this one to, we get here this, our kappa is equal to t dash of t magnitude of this over r dash of t. So that may give me this equal to 2 over 2 plus t square over, we're having here 2 plus t square. Simplify this one, gets here 2 over 2 plus t square whole square. It's just the calculations, and this is my curvature. And we can have many examples. We have a lot of problems given in the book. You can just go there and you can see it. As you know, always putting my notes in the description, and you can just download that one and you get more examples and you get more problems also to do the practice.